Let us now consider the question of how an increase in pressure, and consequently a reduction in volume, will influence the equilibrium of the reaction for ammonia synthesis. In this case, the overall volume of reactants is double that of the products.
As we can see, if the volume V is reduced, the number of moles of ammonia must increase to satisfy the condition for the constancy of Kc.
In accordance with the Chatelier's principle, an increase in pressure causes the system to counteract the external factor and to react by reducing the overall volume, that is, in the direction of increased ammonia synthesis. Thus, the increase in the system pressure is not as high as would be expected from the increase in external pressure.
Therefore, the reaction will proceed in the direction that enhances the combination of hydrogen and nitrogen. That means an increase in external pressure increases the equilibrium yield of ammonia.
A reduction of the system pressure by an increase in the volume of the container will have the opposite result. Some of the ammonia molecules will decompose, and the equilibrium will be shifted to the left, in the direction of the reagents.
A reduction of the system pressure by an increase in the volume of the container will have the opposite result, and ammonia yield will fall.
Let's discuss how pressure and volume factors affect the chemical equilibrium. Only on system with gaseous component will change in pressure because liquid and solid are nearly incompressible. So always remember, pressure only change the position of equilibrium, means shift to the left or shift to the right, but not the equilibrium constant, the K value. Pressure change can occur in three ways. The first one is the changing concentration of a gaseous components, might be reactant or product, changing the volume of the reaction vessel, increase or decrease volume, and the third one is adding inert gas, either is at constant volume or at constant pressure. Based on this equation, if you want to check how the pressure affects the system equilibrium, first of all, we need to identify the number of mole. So for here, for the reactant side, there are 2 mole, and then for the product side, there are 1 mole. But have to check the phase of the component. Always remember, pressure only will react with the chemicals equation that with phase of gas. Gas phase means, okay, so when the total pressure increase by decreased volume, the system is not at equilibrium. Means the QC and KC is different. So if you want to try to reduce the disturbance increase pressure, decrease volume, we will try to reduce it by reduce the pressure and increase the volume. Now the net reaction proceed to the side with less number of mole of gaseous molecule. So based on here, if you want to shift to the side with less number of mole, means the system will shift it to right. The equilibrium will shift it to right. Okay, now when the system shifts to the right, the concentration of PCl5, the product, will be increased. And then the concentration of PCl3 and Cl2, the reactants, will be decreased. So you can represent the concentration by this symbol. Next, how about if decrease total pressure of the gas by increasing volume? Again, the QC is different with the KC, means the system is not at equilibrium. Now the system will try to reduce the disturbance but increase the pressure, decrease the volume. Now the net reaction proceeding to the more number of mole of gaseous molecule. So now you check more number of mole, 1 to 2. So the equilibrium shift to the left. When the equilibrium shifted to left, the concentration of PCl3 and Cl2 will be increased, and then the concentration of PCl5 decrease. If we check, right, okay, these are the cylinder piston assemble. There are two diagrams. The first one, we try to push down, okay, exert pressure on it. Then what happened? The pressure increase, then the volume decrease. Okay, try. Okay, when you push down, means now the volume remain over here. Okay, when you push the piston, okay, remain the volume over here. So the volume is decreased when the pressure increase. But for this one, if you pull up, now the volume is increased. Total pressure decrease. Let's look at this diagram. This is analogy. Just another way to help you to understand. This is congested side on the highway. High pressure, just imagine. If you are this yellow cube car, you tend to go to the side. Which side? Yellow or red or yellow? Which side you will choose? Sure, you will choose the red side. So tend to go to the side with fuel car. Okay, another analogy. This is a big house, high volume, low pressure. Now you feel lonely, want to find more friends to have party. So you go to the side with more people. So always remember, increase pressure, decrease volume. Okay, you will shifted from the greater number of mole to fewer number of mole. Means you will shifted to the side with fewest mole of gases. If decrease pressure, increase volume, okay, so the gas molecule will shifted to the side from fewer number of mole to greater number of mole. So shifted to the side with most mole of gas. Okay, there are a few exercises. So the first one, A, B, C, D, there are 4 equations. Predict the direction of the net reaction in each case as a result of increasing the pressure means decreasing the volume on the system at constant temperature. Explain. So in this case, increase pressure, decrease volume. So you just imagine it's congested, very congested. So you tend to go to the side with fewer number of mole. So from greater N to fewer N. Okay, so let's check one by one. Okay, first A, always remember ignore solid and liquid. So I eliminate these two components. Now here 3 mole. Okay, here is 3 mole. Over here is 2 mole. Okay, go to side with fewer number of mole, means shifted to, go to the side of shifted to right. Okay, 3 to 2. Okay, shifted to right. So for this case, total here 1. Here 2. Okay, you jot down by yourself. Here 1 mole, here 2 mole. Okay, go to the side with fewer number of mole, shifted to the reaction, proceed to the left. Okay, here 2. Here 2 as well. So if the number of mole is the same at the product and reactant side, no change, because total number of gas mole of the left side and the right side is the same. Okay, how about this one? 2. Here 3. Okay, so 3 to 2. Reaction, proceed to left. Okay. Next, predict the effect of increasing the container volume, means high volume, okay, low pressure. So high volume, okay, just now I used the analogy, big house. Okay, now big house, you want to find more people to have party. So you go to the side with greater number of mole. Meaning to the side with most mole of gases. Okay, let's check A, B, C, D, and then have to explain as well. So the first one, 1, 2. Okay, 1 to 2. Reaction proceeds to right. When the equilibrium shift to the side with more mole of gases, then the number of the concentration of 2F, means the F gases, increase. And then over here, F2 decrease. So the concentration of the reactant decrease, and then the concentration of the product increase. Over here, right, since you know what is the product, what is the product, what is the reactant, then you have to mention specifically. Okay. Next, Okay, always remember go to the side with more number of mole. Here, gas, gas, gas. So 2 to 4. Shifted to the right, 2 to 4. When shifted 2 to 4, okay, means the concentration of CH4 decrease, and then the concentration of C2H2 and H2 increase. Okay, now check for this one. Liquid. So I'll eliminate it, this component. So here 1 mole. So, okay, I have to go to the side with greater number of mole, means 0 to 1. Show reaction proceed to right and then produce more CH3OH. And then less CH3OH liquid will form, and then more CH3OH gas will form. Okay, D, here 1, 1, total is 2, here 1, 3, total is 4. So 2 to 4, reaction proceed to the right, and then less CH4 and NH3 means the concentration of the reactant decrease, and then more HCN and H2, the concentration of the product increase. Okay, clear? Now, let's proceed to another factors. Addition of inert gas. There are two conditions. One is at constant volume, another one is at constant pressure. Okay, before we start, right, let's look at another analogy. Okay, just imagine you want to adding inert gas as constant volume. So over here, this is the basket is the volume, and then there are 5 rambutans and then 5 durians. Okay, the question I want to ask, right, if I want to add another 2 fruit, means 2 mango, okay, will it affect the partial pressure of the number of mole of durian and the number of mole of rambutan? Okay, actually it's the number. Okay, just assume durian, the P durian will affect, and then this is a P rambutan. Will it affect? The answer is no. Still remain 5 rambutan, 5 durians. And then what will change is the P total. Total there are 12 fruits. So when adding inert gas at constant volume, total number of gas molecule increase, like just now. Okay, total gas pressure in container increase, but the partial pressure of reacting gases, means just now the durian and rambutan, does not change. Okay, so PA equal to NA RT over V. Okay, the PA and NA still the same. Adding inert gas does not change the volume, has no effect on the equilibrium position. System still at equilibrium. All reactant and product concentration or pressure remain the same. Okay. Addition of inert gas at constant volume. There are two diagrams. First, before addition of inert gas, there are two partial pressure. Okay, gas A and gas B. So P total equal to partial pressure A plus P partial pressure B. So 6 plus 4 equal to 10. Now when inert gas is added, so the P total will be increased, but the PA and PB still remain the same. Means the partial pressure of the reacting gas still remain the same at constant volume. What will be changed? Just the P total. Now let's look at another analogy. In this case, we change the situation, adding inert gas at constant pressure. What means by constant pressure? So just imagine over here, this is the basket, okay, with this volume. I want to ensure that the total number of fruits inside the basket is 10. But at the same time, I want to add 2 mangoes. So the mangoes acts as the inert gas. What can I do? No choice. I want to ensure that the total number remain the same, so I have to eliminate durian, rambutan, and then put in mangoes. Then the total fruit inside the basket still remain the same. Means over here, the total number of durian and rambutan is decreased. Adding the inert gas at constant pressure, the total pressure in container remain unchanged. Like just now, 10. Total there are 10 fruits inside the basket. But the partial pressure of the reacting gases like the rambutan and durian in the container decrease. So over here, the partial pressure of A decrease and then the volume change, means the volume will increase for this time. And then according to Le Chatelier, adding of inert gas at constant pressure shift the equilibrium position to increase the number of mole and the total pressure of the reacting gases. Therefore, the system will shift to the side with most number of mole of gases. Okay. Okay, again, before addition of inert gas, the P total equal to 10. Now I want to constant the pressure still remain the same 10. Okay, but after addition of the inert gas, I want to remain, okay, the pressure, the P total must be the same. So I have to eliminate, okay, I have to reduce or decrease the partial pressure of A and B. Okay, so when the partial pressure decrease, volume increase. So the system shifted to the side with more number of mole. This is the summary in explanation for pressure and volume. First of all, let's check the disturbance. When the pressure is decreased by increase the volume, we try to reduce the disturbance by increase in pressure and decrease in volume. Now the situation is low pressure, high volume. The system equilibrium will shift to the side with more number of mole. If the disturbance is high pressure and then low volume, okay, we will try to reduce the disturbance by decrease the pressure, increase in volume. For this high pressure, low volume situation, the system equilibrium position will shift to the side with fewer number of mole. After the shifting of the system, the Kc remain unchanged. Okay, the product concentration and the reactant concentration we have to base on the equation. Hope you enjoy with this video. Don't forget to subscribe, like and share this channel. Thank you.